Hello friends, this is Sanpreet helping you to understand random variable, probability and statistics and its use case. First of all, before proceeding further, let us understand what is the core of this video. The core of this video is not understanding the mathematics or calculating the random variable. It is strictly going the use case of random variable and how it can increase the sales of any company, of any shop, or how it can help in solving the day-to-day problems. Also, we will understand that random variable and the probability, how it helps in analyzing the result of a random process. I will make sure that you understand each concept precisely and in a simple way. The best part of this particular topic is that if you understand and go into the depth of this topic, it can help you or boost your career in data science and artificial intelligence. Now let us dive into the definition. What is a random variable? We have heard this word many times, even if you are in your plus one plus two or in your graduation, you have heard this term. But now let us make the understanding of this particular term very simple, and let us make it to help you to know where it is used. Random variable is nothing but simply that converts the outcome of a random process into a number. For example, you flip a coin, either you get head or tail. If I write x, capital X is a random variable which is equal to 1 if head comes and 0 if tail comes, this is a random variable. That's all. Second example that I'm showing in this image, like x is equal to the sum of dots on the upward faces of 4 dice. Then what is x? X is equal to 4 plus 3 plus 2 plus 1, which is equal to 7, 9, 10. 10. Sorry, I have written here 6. It is written by mistake and the answer should be equal to 10. But let us understand the meaning of a random variable. What it does that this is a random process. What is a random process? That you are tossing a dice. Whenever you throw a dice, what will happen? Any number will come on the upward face and you write an expression that you toss or you throw 4 dices and you see what is the number which is coming on the upward face of a dice. You add that, it becomes a random variable. So random variable converts the outcome of a random process into a number. But this all you know, but this video is not for that. This video is to help you understand where you are going to use this random variable and probability. We term probability density function or probability mass function. But now where it is used and how it boosts your business, that is the core part of this video. So if you are getting some boring stuff till now, just wait and see the next slide. The first use case of the random variable, I have planned here the two use cases. The first is analyzing the sales of shirts and offering discount accordingly. Suppose you visit any showroom, Namero, maybe Monte Carlo, anything. You see there in the different months there is a sale written that buy 3 shirts you will get 2 free, buy 2 you get 2 free. But have you ever understand or have you ever been curious to know that what is the math behind that, how such calculations are done by the company and provide to you? I hope you should see this slide. In this slide you says that there is a company, let it be there is any company, it has calculated the sales of the shirts over a month and has drawn a diagram to represent the sale. Don't go for these numbers 1 2 3 4 5 1 2 3 4 5. These are, I just put it random, but actually understand the core concept of this slide. Suppose that if one shirt is for one shirt they have sold 450 pieces of that. For 2 shirts together they have sold 350 pieces of that. For 3 shirts they have sold 200 pieces of that. But when you look at the 5 shirts sold together, only 50 pieces are sold per month. try to see here, if 5 shirts are sold, only 50 pieces are sold, and the probability is very less because 1200 is the total shirts sold. 50 divided by 1200 is equal to 0.04. This is a probability mass function. Just a statement. If you are calculating the continuous random variable, you are calculating the probability density function. If this random variable is discrete like 1 2 3 4 5, it is probability mass function. So in the y-axis I draw the probability mass function. Sorry, I have not drawn these figures. Actually this is wrong. I have to draw these figures here, and here in the x-axis it is x, which is a random variable. But try to understand from my statement what I am saying, that the probability of selling a single shirt is very high. Actually it is 0.375. I have mistaken for this, have a sorry for that. And the probability of selling 2 shirts together is 0.29, but the probability of selling 5 shirts is very less. It means that the company, when it makes an audit or analyzing the sales after a month, it came to know that the probability of selling together shirts are decreasing. It means that the revenue is also decreasing. So what they will do is that while selling 2 or 3 shirts, they make a offer to sell the 2 shirts free, like buy 3 get 2 free, and analyzing the money and trying to uplift the sales of 4 or 5 shirts also. So from this probability density function graph with respect to random variable, any company can audit or can analyze the sales and can increase and can see where are the loopholes and can discuss and correct the loopholes. So this is how this probability and random variable comes into play. Sorry for these numbers. Actually these are this should be these numbers. I'm sorry for that. Okay. Next, analyzing the payment methods during shopping. This is another thing. Like you have a shop, the different customers comes to your shop and they pay either by credit card, debit card, or by cash. Okay, so if you want to analyze that how many customers who pay via cash, pay via card, you can know that which medium, like digital medium or cash, which is more influencing. And in that scenario they can also buy the resources to pay the money in digital, like phone pay is there, or they can have the digital card cashless machines there to be installed in their showrooms or in the shops, so that they can satisfy the customer in a better way. So understanding the behavior of a customer who comes to the shop can also increase or boost the business. Like in this case, X is the random variable representing the number of customers who pay cash while purchasing, and this is a binomial distribution where n is equal to 100 and probability of paying through cash is 0.2. So the mean of the numbers who pay through cash is 20 and the variance of a person who pay cash is equal to 16. In this scenario, they come to know that the 20 customers out of the 100 pay through cash. It means that 80% of the customers choice is a digital medium. So they can have more cashless machines in their office. They can have the scans for, they can have the the scans for phone pay or Paytm. So it means that they come to know that 80% of the persons that are coming, they don't choices the cash, so they choices a digital medium. So in this way these kind of stats helps any shop to understand the behavior of the persons who are coming on their shops. So this can help to boost the sales. In this way, these two examples, we come to know that how a company selling the shirts can increase the sale, or a shop which is selling the items can also increase the sale. So these two things are done through what? Probability density function or probability mass function and random variable. And probability and random variables, they go hand to hand. Now when the two things are over, now let's go to the third thing, that how random variable and probability helps in analyzing the result of a random process. Like I have a two fair six-sided dice that are tossed independently. Let m is the minimum of the two choices. Calculate the probability mass function of m. So I draw all the possible outcomes, and here it is a value of m. Sorry, I have written possible outcome. Please replace it by the value of m. Means like when you toss, when you throw two dices independently, there are 36 cases, and you see what is the minimum of the two choices that comes when you toss it. So in this way you will, if you draw the probability mass function versus random variable m a graph, you will come to know that okay, one getting a minimum of one when the two when the two dices uh, are thrown, it is highest probability. So and getting a 6 when the two dices are thrown, it is very less, and it is equal to 1 upon 36. So in this way we can analyze the behavior of a random process. We can get some useful information when a random process occurs, and this can help to solve many problems. Okay, I'm not going deep into the problems which can be solved, but this video is an overview that how powerful the random variable is there, and when it is collaborated with the probability, and when the graphs of random variable and the probability density or probability mass functions are drawn, it helps to understand the statement more clearly. Don't go for the accurate diagrams. So the diagrams are not accurate, but try to understand, try to get the idea from the video. So this video has the two use cases. Let me go to the outline again, that where this random variable is used. There are a huge use cases. The use case in the NAVSBay, in the machine learning, or we can say the lot of problems of ML are solved through conditional probability Bayes theorem, but the base for them is the probability, and the probability it also has a strong connection with the random variable. So if you understand the random variable, understand how it is related with the probability, you can think with the vision that where such things are used, where such things are applied to boost the business. So we have also covered in this small video that how it helps in analyzing the sales of a shirts, or analyzing the payment method during the shopping, and in the end how they helps in analyzing the result of a random process. I hope you like this video, and there are some mistakes in this video which I have spoken. Sorry for that, and thank you again.